Geometry students, welcome to your 1.5 notes on angle relationships. How do I identify and use a special pair of angles? And how do I identify perpendicular lines? Okay, so first we're going to take a look at adjacent angles. And adjacent angles share a vertex. Okay, they share a vertex, if I can write with this pen. All right, and a side. All right, but no common interior points. Okay, so this right here, all right, this right here is an example of what an adjacent angle or adjacent angles looks like, and this is not an example. All right, pretty clear from our descriptors here. So let's move on to a linear pair. All right, so a linear pair, let's change the color of my pen. All right, a linear pair, adjacent angles that add up to, well, if we add up the angle measure of 2 and the angle measure of 1 here, that is a straight line there. So this would add up to 180 degrees. Some of you might have been looking at that and been able to figure that out. Sorry about my sloppiness. This is the first video I've made in a long time, obviously, and so my pen isn't working the way that I thought it would. Okay, so we've got vertical angles. Vertical angles are going to be two adjacent angles formed by two lines. Okay? Boy, I'm not satisfied with the way I'm writing. Come on. Two lines. Okay, so now we're going to talk about complementary angles. And I usually like to write while I'm talking to you, but I am struggling with the pen here. So I wrote it down off screen there. But two adjacent angles whose sum is 90 degrees is going to give you a complementary angle. All right, so you probably guessed that supplementary angles would be two adjacent angles whose sum is 180 degrees. And the way that I like to think about these two types of angles, and the way that I've always kept it straight in my head, is that if I was to give somebody a compliment, it's nice and easy to do that, so it would be the 90 degrees. And if I was to take a health supplement, that is so that I can gain weight. That's what we always used to gain weight when I played football. And so that's how I think about supplementary angles being bigger and heavier than a simple complement, is because I'm trying to gain weight. That's just a little tidbit on how I try to remember those two and keep them straight in my head. All right, I was probably driving Mr. Van Dorn absolutely crazy because I went right past vertical angles and didn't talk about the congruent relationship between some of the angle measures on vertical angles. So I want to kind of circle back to that. One of the very interesting things about vertical angles is you're going to get a couple of relationships of congruent angles. And congruency, hopefully you remember when we created our construction of lines, or we constructed our line segments, and some other constructions that we did, but hopefully you realize that congruency means that I've got something that's the exact same. So when vertical angles occur in geometry, and I'm talking about this picture right up here for just a second. When vertical angles occur in geometry, we know that this angle measure here is going to be equivalent to this angle measure here. All right? And conversely, we also know that this angle measure here is going to be congruent with this angle measure here because of the way that supplementary angles work. That was one of the things I was hoping that you would discover with your usage of the protractors. And so it's a very important concept for you guys to understand in geometry, is the fact that vertical angles will give you some sets of congruent angles. So there we go. All right, so for two acute adjacent angles, I took a look at angle CBD and angle measure DBE. And for two obtuse vertical angles, I need two angles that are greater than 90 degrees, and I'm looking for vertical angles. So we've got a pair, or not a pair, but a set of vertical angles here. So we've got EFG, and we've got, if I can move this over, we've also got we've got I, F, and H. Okay, I, F, and H. And I would also like to point out that on this set of four examples, there are a couple of other options that would be correct that you could potentially come up with. So I'm just going to kind of come up with what I do, and there, just understand that there are some others that are possibilities that could be correct. So we've got two supplementary angles. I just need two angles that are going to come up to 180 degrees. So I'm going to go with angle measure GFH, G, F, and H are my points that come up with angle GFH, and then angle HFI. Angle HFI. Okay, and then we need two complementary angles. So we need two angles that complement each other. That would give you a 90-degree angle. Well, if I know that this angle here is 90 degrees, then I would also know that this angle here would be 90 degrees as well. So this could be angle CBD, angle CBD, and angle DBE. Oops, angle DBE. All right, folks, and for our two angles that are going to form a linear pair, I came up with angle measure IFE, or angle IFE, and also angle EFG. I tried to draw a line there, EFG. Okay, so those two angles there. And so those are my two angles that I used for a linear pair. Okay, so for number one here, on this page, we've got angle measure FGE is equal to 5x plus 10. Find the value of x so that line FC is perpendicular to line AE. So that tells us that our angle measure here is going to be 90 degrees. And it's also equal to 5x plus 10, so I can solve for x by isolating my variable. So if I subtract 10 on both sides of my equation using the subtraction property of equality, I would then have 80 there. I could divide both sides by 5. I could divide both sides by 5, and I would get x is equal to 16. All right, so for number two, if the measure of angle BGC is equal to 16x minus 4, and the measure of angle CGD is equal to 2x plus 13, find the value of x so that angle measure BGD is a right angle. By the way, on both examples here, for example 2, these are complementary angles. Hopefully you picked up on that. So again, I'm going to solve for x. I'm going to combine like terms first. And then I would have 18x when I add 16x and 2x together. And then if I subtract 4 from 13, well, that's going to be 9. Okay, so that's all still equal to 90. All right, and then I can use the subtraction property of equality, and I would get 18x is equal to, this is an x, come on, make it x, is equal to 81. And then I could use the division property of equality, where I divide the same thing on both sides of my equation, and x would be equal to, let's see, if I can divide 81 by 9, that would give me 9, and I can divide 18 by 9, and that would give me 2. I'm just going to leave that fraction. All right, for number 1 here, two angles are complementary, so that tells me that they're going to be equal to 90 degrees. And one angle is 21 more than twice the measure of the other angle. So this is my setup, algebraically, and then I'm going to solve for x. All right, I did a little bit of that algebra for you. I do expect you to be capable of doing this algebra, but this is my work. Now, it asked me to find the measures of the angles, so it didn't just simply ask me what x is equal to. Now, in this particular case, what x is equal to happens to be one of the measures of the angle. So I've got an angle measure that's 23 degrees, and then I've got another angle measure that I need to actually use substitution to solve for. And anytime I use substitution, I need to remember to use a set of parentheses. Golly. Okay, so I've got 21 plus 2 multiplied by 23. Well, this is going to be 46. And 21 plus 46. All right, so when I add 21 and 46 together, I end up with 67. And that makes sense. If I add 67 and 23 together, I'll end up with 90 degrees, so that ends up checking out. Okay, so if the supplement of an angle measure, so we know that supplement's going to tell us that we're going to need to go 180 degrees this time. So the supplement of an angle measure has 78 less than the measure of the angle. What are the measures of the angles? So I set my algebraic equation up like this, and then I'm going to need to solve for x. So I'm going to combine like terms. So I've got 78 plus 2x. All right, if I subtract 78 on both sides, that is a terrible looking 7, I apologize. I would end up with 102 is equal to 2x, or x is equal to 51 degrees. And it's asking me to come up with what the measures of the angles, not just what x is equal to. So if I add 51 and 78 together, I'd get 129 degrees. And so the measure of my two angles that are supplementary are 129 degrees and 51 degrees. All right, so for example 4, determine if the statement can be assumed. What I want you to do, I feel like those would be really good questions for you guys to come up with on your own. And so what I'm going to do with those is I'm going to have you guys work on those and be prepared to discuss those answers with your teammates that you're sitting with. Okay? Thank you very much for your 1.5 notes. We will see you in class.